A
Right.
lot of people don't realize, but Guam Power Authority has probably the most survivable fiber optic network on Guam, bar none. During Mawar, when all the telecoms were had some issues with their service, our internal fiber network did not have a blip. And by the end of this year, we should have all of our substations but two on that fiber network, which will goes a long way to shrinking our cyber security perimeter. That's a, that's one of the big benefits of that. Lowering communications costs and making sure that threat vectors don't come through the contractor into our network. Yeah, so lots of nice innovative solutions that we've come up with during the career, and
Absolutely.
it was a lot of people in engineering and other places that helped support this. So I'd like to give
Okay.
credit where credit's due.
Up for day. It's your innovation coach, Rob Jackson, and welcome to another edition of the Innovate Guam Podcast where we explore all things innovation, technology, and improvement related to the island of Guam. Don't forget to like, subscribe, and follow me on YouTube, Facebook, LinkedIn, Instagram, and Substack. My podcasts drop at the beginning of each week. Also, be sure to check out my Innovate column in the Pacific Daily News every first and third Friday of the month. Our guest for today's episode is Mr. John J. Cruz Jr., professional engineer, utility strategist, and one of the key technical leaders helping shape Guam's energy future. John serves as the Assistant General Manager for Engineering and Technical Services at the Guam Power Authority. In that role, engineering, IT and OT, planning, and regulatory functions report to him. He has been described as GPA's smart grid architect, clean energy transition architect, and communications network architect. Over the years, he has risen through the ranks from communications engineer to systems planning supervisor to the systems planning and operations research division manager to his current executive role today. John has been part of Guam's utility transformation for decades. He helped put GPA on its renewable energy transition path beginning in 2008. John co-led the technical architecture for the Guam Power Authority's Smart Grid initiative and helped advance GPA's use of battery energy storage systems for fast frequency regulation and rapid reserve. Moreover, he wrote a significant part of GPA's Clean Energy Master Plan. Academically, John brings a rare blend of engineering and analytical depth. He holds a BS degree in electrical engineering, a BA degree in mathematics with a business minor, and an MBA. John holds a Guam professional engineer license and is a certified energy manager and a certified energy auditor. Additionally, he is a Solar Energy International Certificate Program graduate with certificates in both residential and commercial photovoltaic systems. John also has experience working at Hughes Aircraft Company, where he worked on radar and special projects before returning to Guam and building a long career at GPA. Ladies and gentlemen, I give to you Mr. John J. Cruz Jr. John, welcome to the podcast.
Thank you for having me here.
So glad. I've really been wanting to pick your brain. You are kind of the guru when it comes to all things energy and power on this island. So it's really great to have you on the podcast. Now, we have a tradition here on the podcast where I asked all my guests, what is your definition of innovation and what does innovation mean to you?
Okay, innovation is about bringing in change. It's about bringing something new, and not necessarily new in the general sense, but even applying something old from other application and putting it to use in a new way or a new application. So it's all about managing change, and for me, it's about trying to frame the question as best you can, the problem as best you can. It's about
Yes.
asking yourself deep questions and not going in and looking for the fast, obvious stuff, right? You need to ask
Yes.
yourself, you need to ask other people, you need to ask stakeholders uh, to help you define the problem and to help you define what the solution should look like.
The
That's
heart of
innovation
real
for me.
root cause analysis.
Yeah.
Yeah.
Yep. And then it's also a little bit about experimenting and having fun. Okay.
Yeah, absolutely.
Yeah.
Okay, so I got a couple other icebreaker questions for you before we get into the meat of things. So you're an engineer and an energy leader. What is your favorite innovation or piece of technology in the energy world right now?
In regarding power systems, there are actually two. There's uh, uh, in advanced uh, 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 battery inverters and battery systems, and AI. The application of both of them will help us greatly improve our grid's reliability, resiliency, and affordability.
The advanced battery inverters, can you explain that a little bit more in detail and why that you think that's so important?
Okay. Okay, so we're going to be moving from a synchronous generator, which is the generators that we have, the fossil fueled ones, right? They're,
Yes.
those machines have been powering uh, 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 grids, electric grids all over the world for over a century, right? Now we're
Right.
replacing them with inverter-based resources, which are the inverters used to in solar PV, in wind, right, and in other battery energy storage systems. And on Guam, we have a wind turbine. We have several large utility scale um, solar farms, and we also have uh, a whole bunch of battery energy storage systems, especially the Hagutnya Power Plant, Hagutnya battery or BESS, right, which actually helps improve our outage performance. It actually stops about 75% of the small uh, 10 to 15-minute outages that we used to have, right? It's made our grid more
Yeah.
resilient that way.
Outstanding.
So with the new inverters, all the new inverters, especially the big battery that we're in the process of bidding out, they're going to have to all run in something called grid forming mode, and that's an innovation, a recent innovation. And that grid forming mode will actually help us keep the system stable, right? And help us manage the grid a lot better. Otherwise, we'd be very prone to voltage collapse, where all of a sudden you'll have a blackout, and you won't even you won't have very many indications that a blackouts uh, is going to occur. All right. In the
Yeah.
past, we used to look at our frequency. We watch it drop. That's because of a deficit in generation, right? A generator trips, and that's what we used to concentrate on. Now we need to also uh, be cognizant that if we if we have a fault, which is a short circuit in the grid, we have to make sure that that fault doesn't last very long. It's cleared from the system very quickly. Otherwise, it'll use what they call a reactive power resources. And then if you don't have enough reactive power resources, the lines and the substations and transformers, they can't keep the voltage up. And then you just out like a light switch. Boom, dead.
Yeah. So I thank you for explaining that more in detail. For my listeners who didn't get a chance to attend last week's Power Conference, a lot of the speakers were talking about the importance of inverter technology and about how that really fundamentally changes the way that you operate, support, and sustain traditional power systems and power distribution. You really have to think differently. You might have to even change some of the ways that you've approached business in the past. So thank you so much, John, for that explanation.
Yeah, I mean, I can go on and on about the technology and all the different nuances of it, but we don't have time, and that's another
Yeah,
time for another conversation, right?
yes. So looking back on your journey, what was the first thing that made you decide you wanted to become an engineer? When did you realize that that was
The moon
kind of your
landing,
all right? So tell me
1969,
about
the
that.
moon landing.
Okay.
I saw that. I saw the astronauts and NASA and all the NASA engineers became my heroes, and I decided I want to do something like that. I want to solve problems, right? It's a puzzle,
Yes.
right? All of those things appeal to me. Uh, it was a good thing that I had decent math skills, so so that helped support my journey towards it. Uh,
Absolutely.
yeah, and uh, especially it's about how you can use technology and science to better uh, to make things better than when we found it.
Yes. Yes.
Yes.
It seems like our generation had those kind of big similar seminal events like the moon landing and different records being broken in the fields of aerospace that really motivated us. Um, Today's generations, it seems like they don't have those big things. They just have like tech entrepreneurs and tech billionaires. But other than that, they don't really have a, you know, event that shapes the world. Let's come together, something bigger than yourself kind of thing. Seems like these generations behind us don't really have that same kind of thing to motivate them. What do you think?
Well, I'm autistic, right? And I used to do the pacing around the table and all of that, and uh, kind of puzzled about how people react and work, right? But I managed to journey myself out of that. And
Uh-huh.
most autistics and most engineers, they like to work alone, right?
Yes.
But when I came to Hughes Aircraft Company, they said, "Oh, you're not only working alone, you're working with other people. You get
Yeah.
design teams because
Right.
at that point working on really complex technology, nobody has it all. So
Right.
it's that seminal influence in terms of, hey, I don't know it all. I need to find somebody to work with me, and then we can collaborate towards a goal, a common goal. And when I became the manager of the Strategic Planning and Operations Research Division, which the GPA John Beneventi created for me, right? That's one of the things I told my people, and how we as a business unit culture approach things. Sport leads or facilitates multifunctional teams, right? That means it's not a
Yes.
team just comprised of engineers. Engineers, we have a good skill set, but it's not a skill set that can solve all problems, right? So you need to have some respect and some uh, acknowledgement of the other things that people bring to the equation,
Yeah.
right?
Operations, sustainment, even administrative functions like finance and HR and IT and
Mm-hmm.
all of that. Everybody collaborating toward the end goal to solve problems.
Yep. Like for instance, we used to have so much trouble with manual energy sense rebate processing, right? And I said, hey, let's go get together. with the all the stakeholders, our customer services group, our finance group, right, our IT group, and customers, and say, how do we define a process and put it on a web application so that people can use it, and it will improve the process and make it faster and easier for everybody.
Absolutely.
Before
Absolutely.
we did that process, right, and that process mapping, and trying to uh, 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 make it more efficient, we got rid of a lot of deadwood that was happening. So things that we thought we needed to do, we didn't need to do, so we got rid of it. We did not have, until we got that working, any applications that went from acceptance of the application or receipt of that application to a check cutting for that applicant. None of it was within 30 days. Now about 50% of applications that have no error on it are within 30 days, which was the goal that we set when we started that journey. And we're continuing with modifying and refining that process with all the partners that we have working on this. The sport division brought it up to a certain point where they cut the processing in half, and then Maripaz from finance was like, she's our assistant CFO. She said, "I'm going to challenge my team," right? And then James Borja from customer services said, "I'm going to challenge my team," and we ended up creating synergies that made it even more efficient and faster, right, than if we had done it just as a bunch of engineers trying to do it.
Yeah,
So
John. So I'm really digging this. I'm like geeking out here because I'm putting on my Lean Six Sigma hat. And when you're talking about this, I can just visualize all of this. And I really love the fact that you all broke down processes and silos from the functional areas and looked at the value from beginning to end of the process, not so much the silo and the functional areas and the way they looked at the process,
I,
breaking down those silos and looking at the value from the perspective of what you're
yeah.
trying to deliver to the customer.
So in the beginning, when I got engineering, when I got promoted, I got engineering, right? There was a lot of siloed elements of that, right? And in the past, managers have thought that gave the impression that the acme of human perfection was the electrical engineer, and I start to laugh every time I see that. Yeah, okay, I say that, but we've got a skill set that's really good and really a valuable commodity, but it doesn't mean that it's the only one. It's the only thing that has value, right? I ran during Smart Grid. I ran our AMI program, which is all the meters, all the command center stuff, through our customer services group instead of engineering. And at the end of that journey, when the DOE was auditing and doing a final review of our project, they thought that we had done it differently from everybody else and that we had done it best,
Mm,
right? So,
yeah, yeah.
it takes a community to raise a child and run a village and all of that.
There you go.
And in a lot of tech, it takes a community to help build the best tech.
Absolutely. Absolutely. Hey,
Yeah.
so let's switch gears now. I want to talk a little bit about Typhoon Sinlaku. Don't want to spend a whole lot of time because I want to talk more about kind of where you're going. But I think it's important to kind of talk early on in the episode here about storm recovery. Obviously, we were hit by a super typhoon, category 5 1, about 2 weeks ago. Obviously, GPA has a huge play in that, and particularly the storm recovery actions. What kind of some of the biggest achievements, lessons learned from Sinlaku so far that GPA has gotten?
Uh, we need to put more backups on some of our smart grid systems out in the field, right? Uh, and I'll leave it at that. We have a tier 2 and tier 3 communication system that we put up. It helps with the AMI system to enable us to see who's out there doesn't have power, for instance, right?
Mhm.
And then some of the distribution automation switches are controlled via our SCADA system, which is the control system for our grid, and they depend on those wireless systems to provide communication out to those switches out on the field, right? So in the future, we need to start spending more time and more money on it. We don't have all the money in the world, so we're doing it gradually. But I think
Yes.
within a few typhoons, we should all get all of that stuff up and running, and we'll even be able to do some of this restoration even faster than we did during Senlaku.
Well,
John
hats off
Benavente,
to your
It's all
hats
also
off to your team, John. Obviously, this storm, you all were like at 99% by I think about um, Tuesday, Wednesday timeframe
yeah,
after the storm. So appreciate the great work from everybody at the GPA team.
yeah. About this morning, there were 181 customers that did not have power, and those are people where there's been major damage to the lines or weatherheads and they're in pockets all over the place, right? But we can identify them and that we're getting to them. John Benavente's leadership is also a big thing that has caused this benefit of faster restoration, right?
Yeah,
I mean, the strategy that he's put forth to deploy all of the resources that we have really streamlined things, right? And it's good to have a leader that you also believe in too. So the
yes,
crews will follow him anywhere, I believe, right? So it
yeah,
also takes it's not only the technology, but it's also the leadership and 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 uh, and the hardworking people like the linemen, right?
yeah,
They're out there and before the winds got too high, they were still trying to uh, keep people and repair stuff and provide them power during the storm. And they had to stand down eventually. But those things that's still dangerous work, right?
yes,
Even under normal circumstances, that's dangerous work. So
yes.
I'd like to shout out to all the linemen and the other people that help support them during this mad dash to restoring power.
Absolutely, absolutely. Um, that's so important. And I know Mr. Benavente has been a passionate advocate of his hardening plan to start trying to bury as much lines under the ground as possible to make Guam more resilient. And there's a lot of things that are driving in that direction. One being the national security implications with the three bases here, and this being the tip of the spear in the Indo-Pacific. But also, if we're ever to expand our economy and start bringing in large industrial operations, manufacturing, et cetera, they're not going to come here if they don't believe in and don't have confidence in the resiliency and the reliability of the infrastructure and the power grid, because for them to lose power means significant schedule impacts and effects to their profit. So, can you talk a little bit about Mr. Benavente's push on this $1.5 billion over 10 years to harden and improve resilience of Guam's power system?
No, it's very much needed. I mean, the Marine Base Guam, and Anderson Air Force Base. Once again, they rode through this power system, through the storm, without really losing power. Right?
Because a lot of their stuff is
Yeah, so
already
they have a lot
buried.
of they've invested a lot of infrastructure in terms of undergrounding lines to the bases, to their bases, right?
Yeah.
I don't believe that Navy has completed undergrounding its interface with us.
Right.
So they have much a bigger challenge until they do that.
Right.
Uh, the the undergrounding of transmission lines, right? It should be really the first step. Uh, and like John Benevente hinted, that's the next 5 or 10 years. Even with the 1.5 billion or 1.6 billion, uh, we can't execute on the 6 point something billion right away. But that initial 1.5, 1.6 billion, that's critical. Uh,
Yes.
then we can bring more resiliency not only to the civilian population but also the military, and that's key. We we I'm having stakeholder sessions based on FEMA's community lifelines, right? And I'm in the middle of negotiating with a contractor to help me do that. The FEMA community lifelines include like medical, transportation, power, and energy, which includes fuel, right? Water, communications, all of that, right? There's 6 of them.
Yes.
I've added into this analysis and this stakeholder outreach the tip of the spear, the military, because for Guam, the military is a key community lifeline. Without it, we might be speaking Chinese or some
Yes.
other thing, right? People. There was somebody that said that the Japanese attacked us because we were an American territory, and that's false. That's really a dumb thesis, because the Empire of Japan was 40 miles away in Rota. Guam, by just the nature of its location and of Appa Harbor, is the best deep water port in for thousands of miles away, right? For
Yes.
thousands of miles away.
Yes.
So the Japanese Imperial Navy would have needed this area if it had any plans for invading the West Coast and expanding its empire. So we
Yes.
are a strategic location that any uh, uh, superpower would want to have in among their territories and as part of their military and industrial infrastructure.
Absolutely. And that's why it's so important. And I don't feel like enough people, opponents, particularly in the federal government, understand that it's not just charity for the local population of Guam to harden in its infrastructure and make key investments into the power grid and stuff. It's a national security um, um, mandate to do this. It's not just we're giving this money because we're trying to make Guam and the local community of Guam happy. It's because what we bring to the deterrence and logistics capability of the United States military out here at the point of the spear in the Indo-Pacific, you've got to have us up and running. You've got to have us up and running. That is why the federal government needs to be taking a lead and putting more money into the infrastructure and the power grid. It's deterrence and it's readiness. Deterrence and readiness of the entire United States, not just the local territory of Guam. So important.
It is extremely important in national defense and homeland defense, and we've made our homes here. So
Yes.
yeah, I mean, we're all American
Yes.
citizens, citizens of Guam, of Guam. We're all American citizens. We die and bleed in in relatively large numbers in service of America, and this is our home. It's part of the United States. We love being part of the United States. I do.
Yes.
There's the deal when somebody said something about our not being getting to vote for president. When I was in the States, I was 18 years old and I voted for president because my citizenship within any of the states, right, which is an artifact of the Constitution. The Constitution says only states can send electors. The only exception to that is the District of Columbia, which the 23rd Amendment to the Constitution gave them the right to do that based on the numbers of electors sent by the state of Rhode Island.
Yeah.
So maybe one of these days some congressman will actually put forth, hey, where's the 23rd Amendment for us? Okay.
Yes, yes. All right, so let's shift gears again and let's talk a little bit about you. Who is John Cruz? Let's get a feel for you before we get deeper into policy and infrastructure. You told us a little bit about what drew you to engineering, but can you tell us a little bit more about your journey through engineering?
When I was going to school, I had summer jobs where I did programming. Right, I did some programming for people, software programming. I developed applications.
Let's go back.
Yeah.
Go back, John.
Yes.
Go back when you were younger here on island.
Okay. When I was young, I really like solving problems. Okay, that's puzzles or whatever. But I read a lot of science fiction. Okay. So science fiction and the moon landing and the Apollo program, right? I was too young to really know like the Mercury program or anything like that. But when the Apollo program began, I was so very interested in it, and I followed it religiously. So when I graduated when I went into college, I took every single engineering course that I could. I ended up graduating with like 210 credits, which is quite a bit. I ended up having 2 degrees on it, but I kind of overloaded on a lot of semesters, just trying to cram all of that stuff and take advantage of the time that I spent at university.
What
Right?
school did you go to and why?
I'm a ZAG. One of these days we'll win a championship, I hope, but a basketball championship. But this year was right. But yeah, so and then I got hired by Hughes Aircraft Company, right, in the radar systems group in the modes development laboratories, and that opened my eyes there to a whole lot of different things. And I worked on a lot of special access clearance projects. I worked on B2. I have 3 modes that are radar modes that are flying on B2. I worked on the Magellan project, which mapped out the surface of Venus. Right.
Nice.
I worked on something they called low probability of intercept analysis for F-15 and F-18. And what that means is that, hey, John, here's a missile. It's traveling this fast, right? How much, and it's got a radar cross section of this. How much time does the pilot have before he gets blown up in order to react, right? I did those little studies. And then also low probability to intercept means how do I get stealthy in my use of a radar system, right?
Right.
If you look at F-15, that's 10,000 watts of power. It lights up the horizon, right? And it's basically saying, I'm big, I'm bad, and come and get me, right? And then, from the 80s and 90s, we started developing more stealthy ways of not only in the airframe, but also in the ways of using radar and other sensor networks, sensor technology.
Absolutely.
Yeah. So
So what made you leave the aerospace world in the CONUS and come back here to Guam to work
yeah,
in
yeah, that's a
power?
story. Yeah, that's a story. My parents asked me to come back for a year, right? I I I I I said okay because they said they were going to give me a piece of property if I stayed and helped them, right? My sister Gloria said the parents need help. You need to come back, help them out, right? And I thought if I get the land, I can sell it and I can buy a condo in Redondo Beach, right? So that's what I was thinking. Okay. So I asked for a year's leave of absence. They granted me that, and I came back to Guam. And then somebody showed up. She had spent 9.5 years from Oklahoma. She's a local girl, right? And she came, and I think for me it was love at first sight. And I called my boss up and said, you know what? I've met somebody really interesting, and I'm going to chase her, right? And that ended up being a long chase for her to eventually agree to marry me. So, but we've been married for a long time now, and I wouldn't have traded it for anything in the universe.
I love it. I
Yeah,
love
and
it.
she didn't want to leave Ireland. She just got back because her father wanted her to come back, and so she did that. She says, "I just came back. I'm not leaving." So I had to go. Okay, I got to find something else to do. So the Guam Power Authority was something I had worked as an intern 1 year in I think in '81, and Andy Balahaja was still the manager of engineering. I said, "I like working with Andy. Let me go. Let me go see if he's got something that he can do for me." And that's where I
Well, what
came
a
in as a
blessing GPA got you.
yeah, I came in as a communication engineer, and I commissioned GPA's second SCADA system.
Yeah.
Right. So and it's been fun. There are a lot of problems at the Guam Power Authority starting out back in the early '90s when there was load shedding, right?
Yep.
And there's not a lot of institutional type problems that some of them that we've already solved, right? Uh, and uh, and that's working with my guys and working with consultants and other people trying to get those technologies in place, right?
Right.
A lot
Right.
of people don't realize, but Guam Power Authority has probably the most survivable fiber optic network on Guam, bar none. Okay, during Mawar when all the telecoms were had some issues with their service, our internal fiber network did not have a blip. And by the end of this year, we should have all of our substations but two on that fiber network, which will goes a long way to shrinking our cyber security perimeter, right?
Right.
And that's one of the big benefits of that. Lowering communications costs and making sure that threat vectors don't come through the contractor into our network.
Right.
Okay, yeah. So uh, lots of nice, innovative solutions that we've come up with during the career, and uh,
Absolutely.
and it was a lot of people in engineering and other places that helped support this. So I'd like to give
Okay.
credit where credit's due.
All right, let's go ahead and shift gears again. I want to talk a little bit about last week's Power Symposium. I alluded to it earlier. Really, that was my first time attending one of those. Thank you so much for the invite and the ability to sit down and listen to all of these great minds talk about kind of where we are in terms of Guam's energy capability and where you're going in the future. Can you talk a little bit about the genesis behind the Power Symposium and what you'd like the listeners to know about this annual conference?
It really began because there was a lot of things being said about Guam Power Authority and renewables and everything, and they wasn't very accurate, a lot of them, right? And a lot of times it put us in a light that we're the bad guys, and we're like, how can we be the bad guys against renewable energy when we're the biggest supplier of renewable energy, right? And so I said, you know what? We need to tell people what we're all about, what we're doing. We need to bring it a symposium, a conference where we bring in all the people that are working on with us, and people in the industry that are working in this space, and try to educate the leaders of Guam and our customers about what we're doing, what's the art of the possible, right? And uh, uh, get them engaged, right? We need to do a better job of letting our customers know what we're doing, and I think this is a big part of it. So I told Austin Shelton, because he every year he goes and asks us for money for the symposium, right? And I think we were contributing a much lower level than we are now. And I said, "You're going to be my best. I'm going to be your best friend." He didn't realize that, but right. So we put this symposium together, idea, and the general manager signed an agreement with them, with the CIS, uh, for us to fund them in, I think, on the order of about 25K, and until we reach 50% renewable energy. So this is a
It's a
long
great
commitment.
partnership that Mr. Beneventi had that much foresight to be able to do that, to create this partnership with the Center for Island Sustainability and commit to partnering and contributing and donating to the annual conference on island sustainability,
Yes,
because it merges the two most important folks, and like you said, it brings you into the inside rather than being on the outside and you're the bad guys who won't change and transform and innovate. You come on the inside and open up your kimono, if you will, and share with everybody, here's everything that we're trying to do to innovate and to go to renewable energy. So that was a smart idea.
yep. And in the beginning, Blue Planet, the Blue Planet people were kind of wary of us as a utility, right? And then we told them, we may be doing it for different reasons, right? But we're supporting this move towards 100%. So just because we have different reasons doesn't mean we're going in the same place, right? May as well align
Yeah,
together on it. So need a smooth path and find commonality, right?
right.
And on the things that we agree with, we can move forward, right? And we
Yeah,
agree on most things. Okay, so uh, uh, so that's the way we've approached it.
yeah, that's a
And
great way to
there's a
do it.
lot. We're involved in a lot of national labs. I made a point to reach out because I said this is too much for us, too big for us. The challenges of transforming our grid and making sure that we maintain reliability, resiliency, and affordability is a really big challenge that requires a lot of innovation and great minds to work on it. Right. So we've
Yeah,
worked.
John, I think that was the most impressive part of the symposium for me, to see all of the different national laboratories and the immense amount of brain power that you had there, showing up and talking about what they're doing in partnership with you to
Yes.
help bring you to the next level. That was very, very impressive to see.
So we have relationships with Argonne National Laboratory, Sandia, uh, the National Laboratory of the Rockies, formerly NREL, right? PNNL, Pacific Northwest National Laboratories, uh, Lawrence Berkeley National Laboratories, Lawrence Livermore National Laboratories, Idaho National Laboratories. So there's a lot of laboratories out there working with us to solve Guam problems.
Yeah, that was so refreshing and so inspiring to see that there was so many extended partners and this reach back capability that you had for brain trust to help you solve Guam's energy issues. Now, I got a question. At the symposium last week, you said something about Guam's energy sector. You said that Guam's energy sector is in a critical phase of transformation. What makes this moment so different from previous years? And why is this a true pivot point? Why is this a critical phase of transformation, in your opinion?
Because we're making the transition in a in a in step, a large stepwise function, right? Boom, right, to 50% renewable energy in the next few years. We need a battery system that will take some of that energy and charge batteries so that we can use some of that energy elsewhere, right? Because we have committed to so a lot of solar PV energy that will end up overproducing during the daytime, and we need to shift that, right? There needs to be some really fast grid controls, and some of those grid controls we've already done and demonstrated in the Hagatnya battery, right? But people don't know, but the Hagatnya battery at one point in time was the most advanced battery in the world, bar none.
Where is that?
That's in the Aganya substation near the church
Oh,
on
wow.
Roy T. Damian Street near the
Yes.
Mungung Church.
Yes.
Yeah,
I didn't realize that
yeah. So
yeah.
we were encountering in a lot of grant applications that that DOE put out that one of the future grid services for batteries was fast frequency response, right? And we were like chuckling because we said we've already had 2 years of operating a battery energy storage system with fast frequency response. So we've cut the ground in term. We've been on the cutting edge in some of these technologies for a number of years now, right? And and the next step is also that we're including in the big battery grid forming inverters that they have to run on the system to make sure that our grid is more stable and we don't fall into voltage collapse. So all of those things need to be in place by the time we get to 50%. So that's the criticalness of it, right? But once we have that infrastructure in place, then the path to 100%, right, will be a lot smoother because we'd already have the systems in place to uh, make the system more reliable and more resilient, right? So now now we can accelerate that. Now,
So
note a lot
John,
of people want to go 100%. They're thinking all of solar and wind, and we work with NREL on a bunch of studies about what is the penetration rate that can be achieved by solar and wind turbine wind technology alone. And because we have the rainy season, right, where I've said that a Dandan solar farm, a 26.5 megawatt solar farm that we're producing for a number of hours at 26.5 megawatts during March, where the rain it's really the driest month of the year, except for this year. There's something happened. I don't know what happened, but yeah. during the rainy season, that thing for a string of 5 days will not go above 1.5 megawatts, right?
Mm,
Right. So even if you have somebody said put more batteries, and I said, what am I going to charge them with? Right.
right,
Yeah.
right.
And the thing is, the wind turbine that we have shows during the trade wind seasons from November and I think to April, right? We have a lot of wind power being, in terms of the size and the capacity factor for that wind turbine, it produces a lot of energy during that time. But then for the next 6 months of the year, the winds calm down and die quite a bit. So that wind turbine barely turns on some days, right? But the rainy season and the calm wind season coincide, right? So we need to get additional power from elsewhere, either it be marine kinetic, right? And those technologies at this point, they're still not at the stage where they can compete uh, with what the solar PV and the wind turbine guys can put out in terms of cost. Our bids, right, for renewable energy are technology neutral. The Public Utilities Commission said, we don't want you bidding specific technologies. We want you to be bidding renewable energy and that all different technologies can compete with,
That
right?
makes
And we've
sense.
been primarily getting solar PV and a little wind in the bids. And the solar PV guys have been winning because their technologies are lower cost. At some point in time, right, we believe those other technologies might reduce in cost. And then they would be a viable bidders and proponents, and hopefully win a bid because they're more cost effective, right?
Yeah,
We're technology neutral, but we're not cost neutral, right?
right.
Right? 20% of Guam households are under the poverty line, right? We want to make sure that uh, uh, to continue to uh, to move towards more affordable power. So everybody's like renewable energy, climate change. Hey, I'm okay. Okay, that's fine. But that's not why we went into it. We went into it because solar PV was cheaper than fuel. And if you add more contracts that are pretty much straight, constant contracts, you stop the impact of the volatility of fuel. Every time there's a geopolitical event like the Ukrainian war or uh, or the Iran war, or we get hit by huge spikes in the price of fuel, and
Yeah.
that in turn causes huge spikes in the price of electricity and energy for Guam. But with
Hey,
fifty
John.
percent of it hedged out, we reduce that volatility to something more manageable. Yes.
So, John, just for the my listeners' benefit, can you let them know when you plan to hit your 50% goal for renewables for GPA?
When did we plan it?
Yeah, when are you planning on hitting 50%
We by
target?
2029. The amount of energy that we have uh, procured under our phase 4 renewable energy is enough to bring us to about 50%.
That's pretty amazing because that's like several years ahead of schedule for the governor's mandate, right? Was the governor's mandate 2035 or was it
2035.
2045? Yeah,
2035 for 50%, 2045 for 100%. And
okay.
that 100%, if renewable diesel, right, begin right now, it's too expensive for us to use. It's about 1.78 times what we pay for our diesel, our ultra low sulfur diesel. But at one time, ultra low sulfur diesel was more expensive than the 0.5% diesel that we transitioned to. If the price parity, if it reaches price parity, right? What does that mean? That means GPA will buy renewable diesel, and then we'll be 100%, and we'll, by not adding a single piece of generation, but running our plants on renewable diesel, right? So that's another pathway that we're exploring, not only by putting other technologies, but also by taking a look at renewable fuels. But that's still
So,
somewhere out there in the future, and so we
so
just
let me
get
talk to you about technologies, right?
yeah,
So I've heard a lot of conflicting and contradictory information when it comes to the value of wind energy here on Guam. So you're a true expert. Um, can you give me your opinion about the value of wind energy as a renewable source um, here on Guam? And can you give the myself and the listeners some insight into the past wind turbine project that they had over at think it was Cross Island Highway, and
yeah.
it sounded like it failed for many different reasons. But can you give some clarity to that?
So it's really up to bidders. I think our wind turbine is a Vernay wind turbine. It cantilevers down, meaning
Hmm.
before a windstorm comes down, we crank it down and then we lock the rotor in place, right? So it's survivable. They use those wind turbines in the Caribbean a lot and on French Polynesian islands like New Caledonia, right? Where
Uh-huh.
New Caledonia is where we get our technical support from for the wind turbine. That firm, had the meetings with us several years ago, 2 years ago, and said they missed our phase 4 bid, and they said that they believe that they could be competitive with up to maybe 80 megawatts of wind turbines. Uh, and they've mapped out the areas where they thought that might be viable, right? But yeah, but the deal is that's very good for when the wind blows, because you need to make sure that uh, 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 you don't oversubscribe that resource, right? Because it's only really available during the trade wind season. Okay, so so there's some viability to it, but there are also some limitations on applying that technology to our use on Guam.
Okay.
Okay, yeah, the
Um,
general manager basically said it's useful during the trade winds. It's not useful when the winds dying down for 6 months of the year. Okay.
okay. I'm asking that because coming up in the next week or so, um, I'm also having on um, Rolando Garcia, who is um, a CEO and founder of Rolly Rack, and he and his engineers have come up with a new design for wind turbine and mounting wind turbine technology, as well as the transmission and how that power is stored. So I'm really interested in hearing about his design and his thoughts and stuff like that. I think they might already have a contract with you guys for phase 4. I'm not sure or not. But yeah, I'm interested in hearing what his thoughts are for wind and his new design and his technology that he's bringing to the market.
Yep. In phase 4, or we've we're still in negotiations with 2 of them, but there were 5 proponents and 5 proposals that we've accepted. Right. It's about 330 megawatts total solar PV array. half of that capacity will be energy shifted in batteries. So the batteries come with the with a solar PV, right?
Yes.
Uh, we're putting our own centralized batteries so that due to the economies of scale, if we bid out for solar, we can get lower solar prices because we've already got this energy storage to accommodate pushing that energy to the nighttime hours, right?
Yes.
Okay. But John B has been asking us to put a phase 5 out in the next year or so. We just need to get phase 4 off the ground completely and finish contracting out with the last two components. After that's done, we can talk about putting on a phase 5.
Okay.
Did I answer your question? Kind of. I mean, I was trying to figure it out
You
from.
did. You did. Let's go ahead and shift gears again. I want to talk now about kind of the future, right? More in terms of like if Guam is to have an industrial future, a way of diversify diversifying the current economy. As we talked already, I'm teaching public administration 490 and 590 course this semester. My students are studying the Guam Transshipment Task Force report, and they're looking and digging deep into how we can implement some of those recommendations to build and attract value-added um, operations like manufacturing, maintenance, repair, and overhaul, logistics kind of work, and those kind of industries here to Guam. Obviously, in order for any of those things to be successful, whether you're talking about ship repair, drone manufacturing, chip manufacturing, small electronics assembly, um, all of that, they're going to need reliable energy and reliable utilities to become attractive. What is GPA doing to make Guam more attractive from that perspective to outside businesses and investors to want to come here so that they have a sense of feeling that they're going to get reliable energy?
Yeah, that's exactly the three things, and that those three things are really the foundation of what GPA is supposed to be doing: is reliable power, resilient power, and affordable power. Right?
Right.
And there's data centers that are popping up, local
Yes.
data
Data
centers, right?
centers are already popping up.
Yeah.
Yeah.
They, in terms of connected load or what those data centers are designed for, there should be about 20 megawatts of data centers, 20 megawatt capable of data centers within probably by the end of the year or soon after, right? But they're not 20 megawatts yet because you need to subscribe, and it'll take them some time to grow, right? Uh, and we've been taking a look at what if there were hyperscale, which means 40 megawatts or bigger uh, data centers, especially regarding any need for the federal government or the Department of Defense for uh, AI-based computing in the defense of Guam. I think that
Right.
that's an area that uh, uh, would be would be necessary, and that people are beginning to realize that that might be necessary. So some of my buddies in uh, uh, in the telecom space are saying that there are active uh, conversations going around about a hyperscale generation data center. So in terms of our thinking strategy, the data centers that we have now, they're popping up in like Tamuning in the middle of congested infrastructure. So they're kind of hard to supply, right? And somewhat kind of hard to back up, right? To find more reliable feeds for them. Sometimes there's only really one feed, and we'd have to do something else, but there's not a lot of room to navigate that and come up with something that's what we think is 100% satisfactory, right? But we have this new KEPCO Jonia solar facility that's going to have to build a substation, and it's required to build a 115 kV substation, and it's going to put a 115 kV line from that substation all the way to PD. If we loop that in with a second 115 kV line, that's an enormous potential, right, for serving hyperscale generation data centers, because that's a lot of power that can be transported and transmitted using those two 115 transmission lines, right? It's also another point that can be used to add more generation at some point. But for me, it also means that I have all of my bad boys, because data centers, especially data centers that have a large percentage of AI, are very funky loads. They go from high to low very quickly, right? And that is something that needs to be ameliorated before putting it onto the system. So I'd be able to do all of that in one location instead of 5 different locations around the island. So having it in that one place with a lot of electrical infrastructure, there's water infrastructure there as well from Fena or from Ugum, right? And because we've entertained fiber swaps, there's about 800 strands of fiber running through that Route 17 that could connect those installations with any place on Guam, or including any landing site that would be on Guam, both current and future. All right. So that's a great place for it, we think. And that would mean that we would have to have work with the government of Guam to zone the place for hyperscale generation, right? And to maybe provide other incentives to bring them in. And one of the things I like about data centers is they consume a lot of power all the time. So if like a 40 megawatt data center came on island and set up shop, and we were able to accommodate that, right? That would be a customer larger than the US Navy. That's a lot of potential kilowatt hours that we can spread the fixed costs, of the bonds and the upkeep and expansion of the transmission and distribution systems, right? All of that stuff. And that's an enormous potential to reduce base rates. So the point that you're looking for a multiple pillars of for the Guam economy is something that we are also looking forward to and trying to engender, because as additional power customers, they'll help pay down and reduce base rates and make it more affordable for everybody.
So do you think this preparation for the future, whether it be data centers, whether it be any other kind of industrial operations, do you see it as an engineering problem or a financing problem, more engineering or more financing? And to scale up to meet a need, how long would you think you need? to actually do some of the kind of engineering projects to lay that infrastructure in place to reliably support a new customer, like what you're talking about with the data center or some kind of industrial operation that's set up on the island.
So in case of the data center at that Catal location thereabouts, right, where the KEPCO solar farm, Jonia solar farm will be at, adding, so they're coming online around January 2008, right? Constructing our own 115 kV transmission line, including procurement, could take about 5 years. Okay, but it's got a lot of things going for it. I mean, lots of fiber, lots of power infrastructure, water, and the land is cheaper than somewhere in the middle of Tuman. Right, so there's a lot of good things for that. And we know that from for other mainland companies have come here and are in the process of building other data centers, that one of the sticker shocks that they have are our construction costs, right? And our construction costs have really ballooned, specifically because there's a lot of military projects and a lot of Guam Power Authority projects, like those solar PV power plants. Okay,
Yeah.
battery will also need construction. So from a finance standpoint, that may be an impediment right now. But when things start to calm down and the investment from the military drop to more sustainable levels, maybe there's a window where they can build larger data centers here at a better price, right? So I'm thinking it's more
So
of
it
a
sounds like
finance
it's
thing.
more of a financing issue in your
That's
mind
correct. For
than
data
it is
centers,
an
I believe that,
engineering issue.
because there's plenty of fiber here. We're one of the most connected places in the universe on Earth when it comes to fiber, and that fiber is on a U.S. territory using U.S. laws and the protection and of, uh, of the federal government and our military, and it links both South. It links both Asia and and North America, and potentially even South America up. Right, so that's a lot of
Yeah.
traffic. That's a lot of and there was a few years before COVID killed it. Right, there was a bunch of people that wanted to put a data center here on Guam, and we were working with them about a lot of U.S. financial companies wanting uh, to move to Guam, because then the laws that govern the financial dealings are American laws instead of
Right.
laws in other places that may not be so benign uh, uh, to these companies, right?
Right.
And if anything does happen to Taiwan, right, there's a lot of financial stuff that can move to further away in a safe zone, which would be us.
Right.
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 So COVID killed that, but the need for it may not have gone away. So
Okay.
no, we just need to put our best foot forward and work on our resiliency, work on our reliability, and work on our affordability, and then I think they'll come, because everything else is here.
Okay. Let me ask you about this. You alluded to it already with the joint Capco area that you were imagining. But do you think that we need dedicated industrial zones? And then within those dedicated industrial zones, you can have hardened utility corridors, you could have redundant feeders, you could have even microgrids and all kind of things, but localize it to these industrial areas. Like, for example, what's going on the Route 3 corridor going up to Camp Blas, and you got the Pacific um, Industrial Park that just opened there. That might be a new area where a lot of business or things will be opening up. Uh, uh, are you in favor? Are you advising that kind of thing to have dedicated industrial corridors?
Yes. I mean, that transmission capabilities there, and we have the Ukudu Power Plant. We're going to
Yeah.
hook up Dededo CT to that ring, right? So there's more power. There's also uh, 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 projects, solar PV projects from Phase 4 that are on the distribution side, right? And also one up there that's on the 34.5 kV transmission side. Each of those has to have a GFM, and a GFM you could start uh, hosting microgrids. So one of
Okay. GFM being
the grid forming inverters, so they could independently come out without any synchronous generation and form a grid to serve a predefined load, right? So one of the grant projects that we're doing with NLOR, National Laboratory of the Rockies, formerly the National Renewable Energy Laboratory, is to look at how we can develop microgrids on island using the resources that we already have in place or will be having in place. So that is another avenue where we can improve reliability and resiliency. Right.
okay.
So
All right.
and when with the Marine Base and Anderson Air Force Base on that transmission loop during the storm, that actually was a microgrid. That was part of the grid operating separately from the rest. So because we severed the south and the north were severed, there were a bunch of 115 kV lines that went down. So uh, those 115 kV lines allow us to transport a lot of power from the north and the south, and vice versa, right? With that 132 megawatt plant, solar plant, right? That's a lot of energy that we need to transport mainly to the north, because the northern part of the island is where most of our loads are. The center of the loads happens to be pretty much near Ukudu Power Plant, which is kind of a, yeah,
Dededo is like the most populous village on the
yeah,
island, and then right below Dededo you've got um, you know, Tumon, Tamuning, Harmon area, which is
yeah,
most of your
yeah,
load. Yeah,
and but so that also adds to our resiliency.
yeah.
Uh, the renewable energy integration study that we did in 2018, that we completed in 2018 in collaboration with uh, the Hawaii lab, HENI, and the Department of the Navy, right? It recommended that for future large generators including batteries and solar PV and renewable installations, that they should be hooked up to the 115 kV. The reason for that is that reactive power flows better on the higher voltage than the lower voltage, right? So having being able to spread that throughout the grid is a is a is is key to making sure that we don't go black on voltage collapse.
Yeah.
Okay. Yeah. I mean, everything ties together. I
Yeah.
have a relay because we're becoming becoming an inverter dominant grid. The inverters don't supply a lot of short circuit current. So that means that in the future, when we have mainly inverters supplying power that are overcurrent system protection relays, they're not going to work anymore. So we've begun a project, and I think it's four years already into it, to change our system protection to overcurrent protection that doesn't depend on large fault currents detections in order to operate. So
Yeah.
so it's taken a lot of different things in order to come to this day where we can say that we'll actually have a grid that's not only renewable, cleaner, uh, helps us manage fuel price better, volatility better, and helps improve reliability, resiliency, and affordability. All right. So
Yeah.
that's why I said we're at a very critical juncture because all of these work streams are headed towards supporting this new grid of ours. Right.
Yeah.
So that's a critical juncture. And at the point that we actually finish these projects, we make it easier for us to expand more renewables into the system.
Yeah,
Okay.
I appreciate you laying out all out like that. And John, you're just full of so many incredible insights. This was an amazing conversation. I really appreciate everything that you've done. Before we close out, what's the big takeaway that you want to make sure all of our listeners get before we get out off the stage here?
That we have this We Care program with the Guam Energy Office, right? We Care Guam. I mean, we're ratepayers too. We're customers, right? And that we listen and we execute. And what we're executing to is improving our services for our customers and in trying to improve and better the affordability. Because we've had since 2011, we've begun uh, uh, marketing research on what our residential customers truly expect of us, right? And we've been executing projects and improvements to try to live up to that standard that they're asking us to do. Notice that
Yeah.
after 20 years, it took us what 90 days to get over Pang Songwa, right? And then it took us about I don't know, a month and a half to get to 90+% on Mawar,
Yeah.
and now it's like a couple of weeks, right?
Yep.
The standards
Yep.
and the requirements are just uh, becoming higher and higher, right? And we're out there to try to make sure that we delight our customers. That's actually one of the strategic plan that we put together in 2022 says. One of the strategic goals is to delight our customers, right? And hopefully, with
Yeah.
all the hard work that we're doing, all the infrastructure that we're putting down, at some point we'll achieve that. We might never
Well,
achieve
thank you.
that, but we could be getting closer and closer to it. So
Well,
in the
thank you for
last,
sharing that insight.
yeah, I can't hear you.
I said thank you for sharing that insight. And if somebody has a question for GPA or they want to know more from our podcast and they want to contact you or part of the GPA team, how can they get a hold of you?
Yeah, we're only scratching the surface, right? So when we started this market research back in 2011, only 51% of our customers uh, were not dissatisfied with us. Okay, now that includes, it's done on a scale of 0 to 5, with 3 being neutral, right? So 49% of our customers truly did not like us as a company. Some were neutral and some actually were satisfied. That stayed constant in 2013 when we did more market research. During the smart grid program, when we continued that research, we got up to 70-some%. And then just recently, 92% of our customers don't hate us, are not dissatisfied with us. But a huge portion of the move is into the neutral place. That means we've moved them from dissatisfied to neutral about us. There's been some movement into the more satisfied, the 4 and the 5. But most of our customers are pretty much neutral about it. So there's a lot of work that we need to do to move those customers that are neutral to us into absolutely saying that they're satisfied with our service. And then, taking that market research and saying, okay, what levers do we have in terms of bettering our service, in terms of bettering our affordability, do we need to execute on in order to get more and more true satisfaction with us? I mean, I think that's that's another thing that I said that is a critical period, because we only have 8% of our customers that really don't like us. Okay? So
it shows that you're incrementally getting better, and that is the road. That is the road.
There is a lot of room for
incrementally
growth.
Get better.
But once we are at a point where we can see the promised land, right? And there's still a lot of work to do, but at least we can see it, or at least see the campfires in it.
Yeah. Okay? Well, John, thank you for being a guest on the Innovate Guam podcast and for helping us understand the engineering strategy and long-term planning behind GPA's work. We really appreciate the work that the GPA team did after this most recent Typhoon Sinlaku, getting power back up online in short order. To my audience, I hope you were inspired and learned something today. I certainly did. Remember to follow me on all social media platforms, including Substack. Be sure to like and subscribe. And don't forget to check out my Innovate column on in the Pacific Daily News every first and third Friday of every month. Until next time, see you, and remember, whether you're at work, at home, or at play, always innovate. Thank you.